All right, my AB kids, this is the last section of Unit 3, and it's called Calculating Higher Order Derivatives. I know we talked about this in class. It really is not a big deal. You can take derivatives upon derivatives upon derivatives. I'm going to show you in a minute. If you have some polynomial like this, you can find a first derivative. You can find a second derivative. Notice 2 hashtag marks. You can find a third derivative, 3 little marks. Or you can find a fourth derivative, and you can keep going and going and going and going by finding derivatives of the derivative. And the reason you want to do that is because, for example, the first derivative tells you certain things about characteristics about the graph of a function, of the original function, and the second derivative can tell you some characteristics of the original function. So in our further study, we're going to be predominantly looking at first and second derivatives and seeing how they can tell us characteristics of the original graph. So this is a notation thing. You can find, if you have a y function, you can find y prime, y double prime, y triple prime. If you get beyond that, they just call it y, and then they put the little number, like the fifth power or whatever it would be, fifth derivative. And it looks like a power, but it's really not a power. Sometimes you'll see it with it in parentheses like that. Same with this guy. You can go f of x, f prime of x, f double prime of x, f triple prime of x, and then they're like, all right, I'm over it. It's f to the n and then of your function x. So again, you could do a fifth derivative, f5, and you'll see an x there. The other one that's kind of weird, and this is coming up often now in things we're doing in BC Calc, is this guy where you've got dy over dx, d squared y over dx squared. Notice it's not the same place. Same with this one, third derivative. That's just a notation for third derivative. When you get beyond that, it's d to the n of y, and then dx to the n. They put them in the power locations, but it is not a power, it's a derivative. So let's try it. If I take this as my function, f of x, and I want the first derivative, I just derivative each piece. Thank God for the power rule. 6x to the fifth minus 8x to the third plus 10x minus 3. Notice the 9 goes away because it's a constant, and the derivative of a constant is 0. Now I can take the derivative of that, and that's going to give me the second derivative. Now I'm at 30x to the fourth minus 24x squared plus 10. Mr. 3 goes bye-bye. I can take the derivative of that. 4 times 30 is 120. X to the third, 2 times 24 is 48x. Mr. 10 goes bye-bye. And I can even take the derivative of that. 3 times 120 is 360, x squared minus 48. And I can keep going and going and going and going. You see how that works? So, finding higher order derivatives is really not that big a deal. You just take the derivative of each piece and keep going down the line. Now, this one gets a little bit more cumbersome because you've got square roots and such involved. So before I even start, I would change him to be able to use the power rule. So y to the 1/2 minus x to the negative, or plus x to the negative 2. So put it in the right form. You know you're going to try to apply the power rule. You might as well put it in a form that you can use. So my first derivative, this is my notation for a first derivative, is the derivative of this. So x to the 1/2 would be 1/2 x to the negative 1/2 plus, this guy would be negative 2x to the negative 3, right? Power comes down, take it to 1 less power. Now I need to take then the derivative of that. So let's see if we can make it so it's a little bit better. I guess the only thing that I really could do is to take away plus a negative, makes this whole thing negative, right? And then look at it like a polynomial. All right, let's take the derivative of that. Negative 1/2 comes down with the 1/2, they become 1/4. X to 1 less power, negative 1/2 minus 1 is negative 3/2. Minus. Negative 3 comes down. 3 times 2 is 6, but that makes this plus 6x to the negative 4th. And so there is my final answer. Now you might see this, normally you don't see negative exponents in Mr. AP's world. So I guess I could really say that this is 1 over 4x to the 3/2 plus 6 over x to the 4th, just to get rid of those negative powers. All right, second question. Find, okay, notation says second derivative of this. Oh my goodness, I've got x's and y's, right? I've got an x term, I've got a y term. That means I'm going to have to think implicitly to find this. To get to the second derivative, I need to go through the first derivative. So job number one is let's figure out what the first derivative is. Let's go for it. Derivative of each individual piece. When you take the derivative of a y term, you got to say you took the derivative of a y term. So sine of y, derivative of sine is cosine of y, but I took the derivative of y, so y prime, or dy over dx, however you want to write that, equals derivative of x is 1, plus derivative of y is 1, but I took the derivative of a y term. Everybody with y prime goes left. Everybody else stays right. Factor out the y prime. Cosine of y minus 1 equals 1. Y prime equals 1 over the cosine of y minus 1. Now I need to take the derivative of that to get to the second derivative, right? Currently in this format, I would have to use Hody-Hyde. I have to use the quotient rule. But I can play games and call this the cosine of y minus 1 to the negative 1 power so that I can use the power rule and not the quotient rule to be able to get there. If I would choose to use the quotient rule, if I went that route, you'd get the same answer in the end. But it's just I'm setting it up so I can use a power rule to hopefully make my life a little bit better. So let's see how this works. If I take the derivative of this, now I'm working towards getting towards the second derivative. In other words, y squared, d squared y over dx squared. I'm going to call it the second derivative. The power comes down in front. The group goes to 1 less power times the derivative of what's inside. Well, the derivative of what's inside, cosine, derivative, negative sine of y, but I took the derivative of a y, so I need a y prime. Derivative of negative 1 is 0. What the heck is this? Second derivative. I have a fraction because I have a negative exponent. All right, let's figure this out. I have a negative times a negative, gives me a positive. I have the sine of y and y prime. In the denominator, I have a cosine of y minus 1 that's being squared. And here's the story with Mr. AP. He does not allow you to have y primes and y double primes that's kind of like two unknown variables. So here's what you know. You know what y prime equals. And you have your choice. We don't like, Mr. AP doesn't like negative exponents, so I'm going to circle the other one. What you're going to do is replace that, and believe it or not, that's your final answer. And it can be big and ugly, which it's going to be, but that's it. So I have the sine of y. Y prime is 1 over the cosine of y minus 1 over the cosine of y minus 1 squared. How about that for a crazy answer? Again, you would have all sorts of different equivalent answers to this. Here's one that's an option. You could have the sine of y. See how this cosine of y minus 1 is the same as this one? It's the cosine of y minus 1 quantity cubed. That would be an equivalent answer. Probably the one you would see on a test, on an AP test. All right, well that's it for the examples of higher order functions. I want to pick a couple problems to do with you. The first one I picked is number 9, and I chose it because it's got e's, and I thought they might freak you out. Here's what the directions say. Find the second derivative based on the given information. Okay, so finding the second derivative. Here's what I've got. I'm going to treat it like a polynomial, but I also have to treat it implicitly because I have x's and y's involved. So the derivative of e to the x is e to the x. Derivative of y cubed is 3y squared times y prime, and the derivative of 1 is 0. So my y prime equals e to the x over 3y squared. All right, now I need to go second derivativing. Can I make this prettier so I don't have to Hody high? I can. I don't know that either way is going to be any better than the other, but if I were to change this to e to the x times 1/3 y to the negative 2, then I'm going to have to product rule anyway. All right, I think I'm going to go back to this piece here, and I'm just going to Hody high it. Can I use this? Sure, but then that's going to product rule me anyway. 6 and 1/2 a dozen of another. All right, bottom times the derivative of the top, 3y squared times e to the x, plus the top times the derivative of the bottom, 6y, but y prime, all over the bottom squared. Let's see if we can make it any better. I have 3y squared e to the x plus 6y e to the x, and y prime was e to the x over 3y squared over, bottom is a 9y to the 4th. Now there's a whole lot of different things that I could say to this. Let me see. Here's again, I've got lots of different things that I could simplify. But if I take, let me just take a look at these guys over here. I have a 6y e to the x, and I have a 3y squared on the bottom. So the 6y and the 3y squared, they become 6 over 3 is 2. This is a y, this is a y to the first, this is a y to the second, so they can simplify. I'm going to go into this box to the right. I'm keeping my first term, 3y squared e to the x, plus 6 over 3 is 2. The y cancels with the other y, and I get e. So I have e to the x and e to the x, add the exponents, I get e to the 2x. This is over y, because the other y canceled. And I've got that over 9y to the 4th. And that is the book answer. Here is an equivalent answer, if you wanted it. An equivalent answer would be e to the x, because you can cancel out your 3y's and such. E to the x minus 2e to the x over 9y to the 5th. That's if you take and you get common denominators and work your way through this whole thing. So an equivalent answer. Again, you've got options on the board if it were a multiple choice question. The other one I picked, let's see what else we got. Let's go with number 16. All right, here comes 16. This one, the directions say, evaluate the second derivative at the given point. Okay, so 16, that's what we're going to do. So evaluate the derivative. Well, I've got an ln of x and I have an e to the y. Again, I need implicit, but I also need the product rule because I'm multiplying those two things together. So they tell me, luckily for us, they tell me that this is the first derivative. So all I need to do is derivative this to get to the second derivative. I don't have to do it twice like I've been doing in the other examples. So if this is my first derivative, what's the second derivative? Let me product rule. So I have, I'm going to call it y double prime, just because it's easier than writing all that other stuff. The first times the derivative of the second, ln of x times e to the y times the derivative of the power is 1, but it's a y prime. plus the second e to the y. And then I have the derivative of ln of x, so that's 1 over x. And then that's it. Then they want me to evaluate it. Now there's a couple things that I can do. I can stop now and evaluate it. I've got it all formed out. Or I can simplify it a little bit more, see if I can make it any prettier to be able to figure that out, to be able to simplify it better. Let's just try plugging in. When I did it on my work, I made this prettier, but let's see if it works better, if it can work from here. Ln of x is e, so this would be the ln of e, times e to the y, e to the first, see how my y is 1, times, y prime, let's go up here, y prime. That would be the ln of e times e to the first. Do you know what the ln of e? Do you remember that? Ln of e is going to be 1. And 1 times e to the first is just an e. So this y prime, and it's going to actually come into play here too, this y prime here is just an e. Now I have a plus sign. E to the first times 1 over x, which is e. All right, we just set up here, ln of e is 1, so if I'm looking for my second derivative, this is 1, that cancels out. E to the first, that gives me e squared. This gives me e to the first over 1 over e, or times 1 over e, and they cancel each other out, so this is plus 1, and that's my answer. That's what I would get if I evaluated. So don't let the e's freak you out, they're really not that big a deal. Next one, let's try... Let's try number 26. By the way, let me go backwards. Let me try. I'm looking at the directions here and seeing which ones are different. Numbers 20, 21, 22. You have three different situations here. They want you to find the following. So this is the second derivative of f, and then plug in a 2. You're going to find the first derivative, you're going to find the second derivative, and then plug in a 2 and evaluate, so you'll get a number answer. This one wants you to go to the g function and find the third derivative, and then plug in a negative 3. This one wants you to find the second derivative and plug in a 4. So take h, find the second derivative, plug in a 4, and then multiply by 2. And that'll be your final answer. So don't let that set value up. It's really not that big a deal. But 26 brings up kind of an interesting thing, and this happens sometimes with the AP exam, that they'll give you questions like this guy. All right, 26 is the last one. Let g of x be the function given by the cosine of negative x minus sine of x plus 6. Which of the following statements is true for y equals g of x? Well, if I look at this, they give me, this is a fourth derivative involved, this one's a fourth derivative involved, this one's a second derivative involved, this one's a second derivative involved. So apparently I need to get to the fourth derivative to be able to answer this question and make the comparisons that they want me to make. So let's just go on a journey. Let's find the derivatives. The first derivative is going to be, derivative of cosine is negative sine, but that negative sine of negative x, I'll write it this way, negative sine of negative x then gets multiplied by a negative 1 because that's the derivative of the angle. So it's going to be a positive sine of negative x. Derivative of a subtraction sign. Derivative of sine is cosine. And then the derivative of 6 is 0. Okay, there's my first derivative. Maybe I'll look at it this way. The sine of negative x, this is sine of negative x minus the cosine of x. Let's go for a second derivative. Second derivative, the derivative of sine is cosine, same angle, but times a negative 1. Derivative of cosine is negative sine, that makes this plus the sine. Here's my second derivative. Going for a third derivative, Derivative of cosine is negative sine. That makes it a positive because there's a negative out already of negative x. But I still need to multiply that by the derivative of negative x, which is a negative sign. So it turns, you got like 3 negatives going on in there. And then the derivative of sine is cosine. So there is my third derivative. Let's go fourth derivativing. Derivative of sine is cosine times the negative 1, but you already have a negative 1 in front, so that's negative times negative is positive. And then I have the derivative of cosine is negative sine, so instead of it being a plus in the middle, it's going to be a minus a sine of x. Now I can make a comparison. So if I look at this, look at how that relates to the original. Can you see it? If this is my original equation, I'm going to change colors here. My original equation is g of x. They're calling it y in some of these, so g of x is the same thing as y, equals the cosine of negative x minus the sine of x plus 6. Then I could say, I'm making a comparison with these guys, that if I move the 6 to the other side of the equal sign, y minus 6 equals cosine of negative x minus the sine of x, and we know that this is the fourth derivative of my function. So guess what my answer is? It's A. Let me move that over a little bit so you can see it. Whoop. I lost you on the side. There it is. If my function was y equals cosine of negative x minus the sine of x plus 6, I can move the 6 over. Cosine of negative x minus sine of x is my fourth derivative, and so you can see how that matches with part A. So that was a little challenging, but that's it. So that's section 3.6. Shoot me an email with questions, and I will see you in class.